Hey everyone, now we're going to learn how to stretch, shrink, and reflect an absolute value function. And, stretching kind of looks like this. We're stretching the function away from the x-axis, which makes it a thinner v. Shrinking it shrinks it closer to the x-axis, which makes it a wider v. And then reflecting it flips it over the x-axis. So it flips it upside down like my little brain guy here. Okay, and the variable that deals with this is this a right here, outside of the absolute value of x, and it's being multiplied. So it's not added or subtracted like the other values in the previous video. This is a variable that's multiplied by the absolute value of x, and this is how you will stretch, shrink, and reflect, depending on what this a value is. So let's go to Desmos and figure out what values stretch this guy, what values shrink it, and which values reflect it. So flip it upside down to make a downwards facing V. Or I guess it's not a V at that point, a mountain. So instead of being a valley, it's a mountain. Okay. Here we go. So in Desmos, I've created my handy slider A again, and I also graphed the absolute value of x, which is this black graph up here, this black V up here, and then the negative of the absolute value of x, which is this black mountain down here. So let's figure out how we can stretch this graph. So make this a thinner V. Stretch it away from that x-axis. So let's see. Let's move it here. Oh. All right, so this is making it wider. I'm at 0.2. Let's keep going higher. 1. Okay, that's just the absolute value of x. And I go higher than 1. And now we're making it thinner. So we're stretching it away from the x-axis, stretching those y values up, and making this a thinner v. And notice that a value has to be larger than 1, because 1 was our cutoff point here. So what happens if a is less than 1? That, my friends, is how you shrink this graph, how you make it a wider v, how you shrink those y values to be lower. Now, go to 0. Okay, 0 is just a line because 0 times anything is 0, and now you end up with y equals 0. Okay, now let's go negative. Any negative number is how you end up with a downwards facing v, or a mountain. So notice that this negative 0.6 is still a shrink, but it's a shrink and a reflection. So two different transformations with one number, because it's negative and it's between 0 and 1. The absolute value of 0.6 is between 0 and 1. Now we'll keep going lower, negative 1, and then greater than negative 1. That is a stretch as well. Stretches away from that x-axis, and it's a reflection because it's negative. Okay, let's go back to these notes, and we'll summarize. Okay, so I've got a lot of symbols here, so we'll talk through it. So this function g of x equals a times the absolute value of x, where a is greater than 1, where a is larger than 1. What does that do when a is larger than 1? This stretches the graph. So, and I'm going to say vertically stretches it because it stretches it up, stretches those y values, makes it thinner. So vertical stretch. Vertical stretch. And you can say by a factor of a, whatever that a is. So for example, if a is 3, that means your slope will be 3, as opposed to if a is 2, your slope would only be 2. So 2 would be less steep than the factor of 3. Okay, what if 0 is less than a is less than 1? This means what if a is between 0 and 1? So it's a fraction that's less than 1. This is a vertical shrink. The v got wider, it's a wider graph, by a factor of a. Whatever a is, 1/2, 1/3, 1/4, otherwise known as 1/4. Okay, finally, negative a. Doesn't matter if it's a shrink or a stretch. If you have that negative number, it's always a reflection over the x-axis. Let me spell this right. Reflection over the x-axis. That's what that negative sign does. And if this A, if it's like a -3, then that is a reflection and a vertical stretch. So 2 transformations. All right, let's take a look at a couple examples here. Graph each function and then compare them to the graph of f of x equals the absolute value of x, and we'll define or describe the domain and range. Okay, so I'm going to do the same thing like I did in the last video, make a table of values for one of them, and then use a different method for the other one. So let's do this table of values again. So we got x and q of x. Let's see, 2. We'll do the same. We'll do -2, -1, 0, 1, and 2. So these are the values that we'll plug in for x. Let's see, if we plug in a -2 for x, that's the absolute value of -2, which is 2, times 2, which is 4. All right, how about -1 plug in for x? The absolute value of -1 is 1, times 2 is 2. All right, plug in 0 for x. The absolute value of 0 is 0. 0 times anything is 0, so 0 times 2 is 0. Cool. Okay. And then plug in 1 for x. The absolute value of 1 is 1, times 2 is 2. You might notice a pattern here. If you plug in 2, you will get 4. All right, so -2 up 4. That's this first point, -2, 4, and then -1, 2, over -1 up 2, 0, 0, 1, 2, and 2, 4. Okay. I want you to take a look at the slope of the right-hand side of this V. What is it? Rise over run. We're rising 2. We're running 1. 2 over 1. So the slope is 2. That is no coincidence. We're going to use that for this other graph. Okay. Oh, sorry. Before I do that, let's talk about the domain and range. So the domain of this graph is how far left and right this graph goes. What x values are there? All reals for absolute value. How about the range? How far up and how far down does it go? Notice that this y, the lower bound is 0, so that means y has to be greater than or equal to 0. Okay, let's take a look at this next one. We got a -0.5x. All right. So you can create a table of values just the same. That is fine. Or you can say, all right, I know what this 0.5 is going to do, and I know what this negative is going to do. So this negative is a flip. Flip over the x-axis, which means our v is going to point down. It's 0.5. It is the new slope on the right-hand side, and we know the left-hand side, it just mirrors the right-hand side. So remember that this 0.5 is the same as 1/2, so I'm going to write this as -1/2 times the absolute value of x. So that means the slope is -1/2, or the slope is 1/2. Okay, and it points down. So since we're not moving left or right, you know the vertex is at 0, 0. We're not moving up and down either, so the vertex is at 0, 0. Now, the slope is going to be 1/2, and it's going to go down, which means our first point, so that means we're going to go down 1 and over 2. Down 1 over 2, right here. And it's going to mirror on the other hand side, so down 1 over 2. And then pretend to draw the lines. Down 1 over 2 would be right here. Down 1 over 2 would be right here. And that is the graph of this guy. Now, domain and range. Domain, how far left, how far right does it go? Forever and ever. And the math way to say forever and ever is all real numbers. Or all reals. Now, range. This is going to be a little different because we haven't dealt with a downward facing absolute value graph yet. So the range goes down forever and ever. But the highest y value is 0, which means that y is going to be anything less than 0, and it includes 0. So y is going to be less than or equal to 0. Instead of over here, right, greater than. So now it's less than or equal to 0, because 0 is our highest y value. It's the highest our graph will ever go, that vertex. All right, so let's recap. Adding this negative will flip your graph. Having an a value that is between 0 and 1 will shrink the graph, which makes it a wider v. And having an a value that is greater than 1, whether it's negative or positive, so the absolute value is greater than 1, will stretch the graph and make it thinner.